Awesome. So I'll get started. Hello, everyone. Welcome to the CSUA LaTeX workshop. Today, we're going to be covering a couple things. First, so this is some LaTeX code, which looks intimidating, but we're good. By the time this is over, you'll see this is actually not too bad. And second is the beauty of LaTeX. The great reason to use LaTeX for all your homeworks is that even if what you're writing makes absolutely no sense, it's going to look beautiful. So how do we accomplish this? So welcome to the LaTeX workshop. And you're not going to be allergic to this LaTeX. So here's an overview about the CSUA LaTeX workshop, what we're going to go over. First, we'll briefly cover the pronunciation of LaTeX because I'm hearing a bit too much LaTeX. Then we're going to go into syntax and commands, the kind of high-level overview. Then we're going to talk about kind of some strategies to like cool features and customization options that you can have for LaTeX. And then finally, we're going to end with some examples, editing, and debugging. And after that, we'll go through questions. So the way I want to structure this is to be really adaptive to what y'all are looking for. So this is good, in addition to being hello. So I'm just going to repost the links for the slides and the overlay. So yeah, so this is a high-level overview of the presentation. And as we get going through this, feel free at any time to post any questions you have in the chat, and I'll stop intermittently to ask for questions. So without further ado, is everyone able to, before we get started, is everyone able to use the links? Everyone able to click on them and either clone or make a copy of the Overleaf project if you want to follow along. Okay. Overleaf. Okay, let me fix that. Looks like there was a bug in the Overleaf. You know, I checked it. Okay, let's check. Okay, it should be fixed. Can someone try the Overleaf link again? At csu.org/overleaf. Exact same link should work. Awesome. Glad that that's working. Hello, people who are just joining. So I'll just go back to this. All the code that I'm going to use today is able to be found online. And so as we go through this, if you want to follow along, feel free to do so. So quick pronunciation note on LaTeX. There's an audio here. I didn't turn audio sharing, but it's not latex. It's either LaTeX or LaTeX, whichever you prefer. And why do we use LaTeX or LaTeX? The reason that we use LaTeX is that we want to make a lot of things look pretty and be like reproducible on many different machines, right? It's a language for making really nice documents. And so usages that you'll often encounter are for research papers, homeworks, labs, resumes, English essays, because the citation system is really nice in LaTeX, and also analysis of Minecraft speedruns. These are some common use cases you might see in the wild. So how do you make PDFs, like really nice looking PDFs with LaTeX? There's overall 3 methods that people commonly use. So the first one is to use a text editor such as Vim, Sublime, Emacs, and some sort of LaTeX compiler. If you really have a customized, specialized editor setup, this is a great option. This is very useful for very fast editing. There's a lot of plugins that will allow you to do tricks that you're unable to do on tools such as Overleaf or TeXmaker or TeXstudio. So This is also the one that has no reliance on internet connection. The second one is an online editor, which is most commonly Overleaf. And Overleaf is kind of like an IDE, right? So if you've ever used, like any like sort of IDE-like feature, you'll get a lot of it. So you have syntax checking, code completion, all things that you can get in Vim, but you have to kind of add it yourself in Vim, where it's default bundled in something like Overleaf. The other big benefits of Overleaf are automatic packages import and sync between computers and collaboration. For example, if you're writing a research paper or working on a project and need to collaborate on LaTeX with 3 or 4 different people, then Overleaf is going to be a really, really great option. Although you can use, you can integrate Overleaf with Git or use Git by itself if you want to do that. But Overleaf is kind of like, it's like Google Docs, right? You could use something fancier, but it's really nice for collaboration. And so I will demonstrate these two, and I will be able to help you debug these two. There's also LaTeX IDEs, which is not something that I've used often, but it has kind of a few more perks. But the trade-offs are that you don't have the online ability or the customizability of the text editor. Okay, any questions so far? So I guess you have videos off, so it's for show of hands, you can either do the reactions or whatever you want. But for how many people here use a text editor or something like that and want to try using that for LaTeX? How many people here are going to try to use Overleaf and want to try Overleaf for LaTeX? Either raise hands or reactions, participants. Okay, so it looks like people are going to use Overleaf for this purpose. So let's go for Overleaf then. So awesome. Part 1 is going to be, how does LaTeX work? So we're going to, for this one, I'm going to be mostly focusing on kind of the project if you're following along in the Overleaf, I'm going to be focused on the intro.txt. So where we're going to start is the most basic level. Documents are going to kind of be in between 2 different tags because LaTeX is a tag-based language, right? Like something like HTML, we're basically going to have a lot of things like begin and end tags, which are going to say where things start and where things end. The most basic of those is the document tag, right? So if you have a document and you kind of put things, whatever you put in between these tags is going to be displayed. So for example, in intro.txt, I can display that here. Oops. So are you seeing intro.txt right now? So are you seeing intro.txt right now? Thumbs up, thumbs side, thumbs down, or raise hand if you're seeing. I see some people are on the, are actually already on there. But, okay. Everyone's able to see my screen with the Overleaf. Thumbs up, thumbs side, thumbs down. Awesome. So I'm seeing some thumbs up. So what we're going to do here is this is the most basic of LaTeX. And if we compile it, we see hello world on the other side, right? So this is kind of the most basic syntax. Whatever you put in here is going to be displayed. So the first thing we're going to do is we're going to show you that LaTeX is very different from a typical like word editor and is more like a coding language. And so how do we see that? Well, basically, I'm going to make hello and world on 2 different lines. Now let's see what's going to happen. Wait, nothing changed. And the reason for that is that LaTeX is not a direct translation from what's on the left to what's on the right. It's not a direct compiler. It's going to take whatever text you put in and format it to look as good as it can. So if you want something specifically, you're going to need to format it to look like that. Now, there's a couple of ways that we can make this work on multiple lines. So the first one, here's some that we're going to introduce. So yeah, sorry, I'll go with document later. So some that we're going to introduce, I will discuss later. But as we're thinking about that, we have to think about for this doc, like how does this know what to do? What kind of file to make this? So this is something called the document class, which is the only line that I didn't explain, is just telling what kind of document it is. So for example, an article is used for almost everything you'll do in undergrad. If you want to do a presentation, you can use Slides or Beamer. Other than that, or if you're writing a book, there's options for that. Reports is usually for things like thesis, like a thesis, but overall, you'll probably be using article. So to get hello world, we just type this. So let's say if we have a single line break, right? If we have a single line break, as we saw, nothing happens. But what we can do is if we put 2 line breaks, that's us telling the compiler, hey, I want a line break here, okay? We can also specify that with this double slash here, this double backslash here. And this will tell the formatter that this is how we want to format it. It's the line break. So there's subtle differences between each of these things. So for now, I'm just going to use this multi-line so that they're all lined down. Now, when you're using this in practical context, there'll be more sections running around, more containers. But for now, everything is just inside of this document, everything from begin document to end document. And it's just going to read it in and print it out. Okay, now let's try something that's a little bit more complicated. So yeah, these are 2 different ways to get multiple lines. So one thing we're going to try is I want everyone, so if you have the LaTeX, if you're able to access this LaTeX, just to kind of test your understanding, take it and you can see if you go to menu, you're able to copy the project. Try copying the project, give it a name, and edit it on your own. And I want you to try to add the following. Print a haiku with just 1 line of text other than this document class article, begin document, and end document. So I want you to try, you can Google a haiku, you can do whatever. I want you can write your own live. I want you to try to just get in the hang of how you would format multiple lines. And just to kind of test this workflow. So anyone having issues copying? As a reminder, you go to menu and copy project, and the link is csua.org/overleaf. So feel free to jump in with questions at any point. And I guess, how's it going right now? Thumbs up, thumbs side, thumbs down. Thumbs up is you're good to go, you finished it. Thumbs side is still working. Thumbs down is stuck on something. So if you have video off, or if you have, so if you have video off, you can use the reactions or type in the chat. Looks like everyone except for me has video off, so thumbs don't really work as well. That's okay. But I see 1 response, thumbs up. How are other people feeling? Okay, so 2 thumbs up. Let's get more engagement. 3 thumbs up, great to see, great to see. It'll probably go away after, but you don't have to spam click. So I'll keep track of that. Can you get a 4th or a 5th? Okay. So this is roughly what it should look like. I'm going to say, so let's see if this I haven't compiled this yet, so we'll see if I got it right the first time. Awesome. So I wrote a little haiku. A true LaTeX fan doesn't fear compilation. Errors are constant. In slight irony, I did not get an error there, but that's okay. But the core idea is that all LaTeX is a bunch of text and you telling the compiler, hey, this is how I want you to handle it, right? So here we're just telling the compiler to use different lines. This is really helpful when you're writing a paragraph and you can determine how you want to kind of break the lines up logically in your code. So your code is really clean and LaTeX will handle how it looks on the other side. So when you're formatting, you'll start to pick up how you like to view your code, but that's a person-to-person thing. So next thing I want to try is some kind of use some special symbols. Right now we're only doing text. So let's say I put in the CSUA sells bottled water for $1.25. Already Overleaf is telling us that we have an error here. So you can tell something is wrong. I put, Richard and Madison are our event coordinators, or the set 2, 3, 5, 7, 11 consists of only prime numbers. Oh, there's errors all over the place. That's not good. So how do we solve this? Well, the important thing to realize is that this is code, not like the text. So certain things have a special meaning in code, right? So in this code, we get some errors. And so these are the special characters, the main ones. A $sign. $sign will be used for math. Percentage, which will be used for percentage will be used for commenting things out. Underscore, which will be used for subscripts. We'll discuss that later. The curly braces, which will be used for arguments. Ampersand, which is used for alignment. And slash, which is used for escaping characters and commands. I see something in chat. Okay, so no, thanks. And so as we're going on, if you want to type these characters, we need to escape them using a backslash. Or if you want to type a backslash, like literally, you need to do /backslash because two of these is a line break. So let's practice this. So everyone on your own, take these 3 lines and just use your backslashes and try to figure out, so it's going to look something like this. So if you want to follow along in your own Overleaf, feel free to make those edits. And then when you recompile, you see that it generates it correctly. So if for some of those who are following along, one thing I want to point out that's kind of cool is that for something like Overleaf, it will still compile even if you put an error, right? If you put something that's wrong. You'll see this output like here that's telling you that there's an error and the text gets all messed up. And once we get through Mac mode, I'll come back here and explain why this is the case. Okay. But any questions on special characters and escaping? Okay. Seeing none, I'm just going to mention, on a high level, my goal is not to teach you every piece of syntax that you'll ever use. My goal is to just give you the high level framework to approach this. And then you're going to use tools like Google, Text Stack Exchange, and Detexify to figure things out, right? Detexify is this really great app where you can, someone either pop in chat or say out loud a symbol, like any weird symbol you think of. Sigma, let's do an uppercase sigma. And ta-da, it will give you all the things which correspond to that sigma, right? And I actually don't know if that's how you're supposed to write it. Yes, lowercase sigma, it'll automatically tell you what the symbol is with the command. And this is the greatest thing to ever be invented if you're using LaTeX. So For debugging symbols, Dtexify is your best friend. For debugging like commands, Google is really good because you can give like a description of like plain text what you want it to do, and it'll find something to help you. So let's go back to the slides. Okay. So now let's get to math, what everyone's been waiting for possibly. So you can put math inside $signs, and if you put $2 you'll get the math that is centered on its own line. And there's other ways to do this. So if you go to math.tech, I've outlined 3 ways that we can get into math mode, right? So for inline, you use the $1 sign. For multi-line, you can use $2 signs. And you can also use this like open bracket, close bracket. Now, in terms of what happens in math mode, things end up looking like different commands work in math mode, different commands work in regular mode. And things look different. So x, if I write, here, for example, x versus x, you can see that these 2 things are going to look different. Let me zoom in here so it's easier to see. You can see x and x look different. Certain things only work in math mode. So for example, here, you can see that there's an error because it's inserting the sigma for me, right? So it's erroring out because the sigma can only appear inside of the math mode, and it's automatically placing it for me. So it's inserting its own sigma there, but that kind of unfortunately makes this, so this is, some things only appear in math mode. Okay. So one thing you can do is if you want to make this math centered, you could just substitute this for a like something like this, right? 6. And then it'll print it out on a full line with centering. Okay. The difference between these 2 things, the like double $sign and the open bracket, close bracket, is a little bit complicated. I'm not going to go over it here. Generally speaking, if you want to develop good habits, the second one is better for a couple reasons. But everyone uses the first one, and like for a basic tutorial, this is like be out of scope. But this is one of those like good habits which I can potentially instill in you that might help you later down the line with some formatting stuff. Okay, so I'm going to outline some very common math commands to use in math mode. I renamed this file from math2. So I'll show this in a moment with a bunch of other things. So square root is like this. For superscripts, you use a caret, underscore for subscripts, frac for fractions, and then less than or equal to, greater than or equal to, infinity, plus minus. Don't worry, if you go to additional commands.tech, I have an example that uses a couple of these. So, and then integral. So on additional commands, I also have some other stuff which I'll explain later. But if you want to try on your own, try to write out these 2 commands. X cubed plus 3x squared plus 3x plus 1 is equal to 0, and x plus 1 cubed is equal to 0. Try to write these out either in a new file or in one of the existing files. Put a thumbs up whenever you're able to make it work. And if you came here recently, you can go to csua.org/overleaf, copy the repository, copy the project and edit it on your own. And if you finish that, feel free to go on to this one. I kind of spoiled the mistake there. Okay. How's it going? Thumbs up, thumbs side, thumbs down, or you can put in chat. It's going. Okay, I see one thumbs up and no other reaction, so I'm going to briefly go over this. So basically what you should encounter is that if you want to do a simple exponent, do we have to escape parentheses? No, you do not have to escape parentheses. Great question. So if I were to make a new file, if I were to just make an example quickly to illustrate this point, oh, I put it in there. Okay, so we can do article. If I do something like this, you can see that it's going to compile correctly. Sorry. Yeah, so you don't need any escaping. And so for doing this, all you have to do is x cubed plus 3x. And I can also increase the size here. X cubed plus 3x squared plus 3x plus 1, as well as x plus 1 cubed. So these two methods are going to all print on the same line because we're not using line breaks, and basically give us the results that we want. However, if we want to do it to the 30, what's going to happen is if we don't use parentheses, let me just make this on the line. If we don't use any curly brackets, the 0 is going to drop down because this caret is only taking the next character as an argument. So what we're going to do is curly brackets, you can think of it as like, this is the argument I'm passing in, right? So I'm going to pass in 30 as the argument instead of 3 as the argument, right? Because by default, all these things will take the first character they see as their argument. So to replace that with what you want, you need to use curly brackets. So this is some summary of that. It's basically the argument passing in LaTeX. If you did square root of 2, it would automatically work, but square root of 23 or x to the 100, all these things won't work. Okay, so now I'm going to do something a bit more challenging. Using the commands that I gave you here. As a reminder, I want you to try to print out the quadratic formula. So this is a little bit of review, a little bit of, review in terms of material, but that's some new content here. So some helpful functions to know is p/pm is for plus minus. Frac takes 2 arguments. So for frac, it's use fraction, numerator, denominator. Okay, and I want you to try to go for this one. Okay. How's it going? Okay. So what you'll end up with is something like this. Oops, I forgot to mute this. And you'll get x equal to something like this, where we'll basically nest these commands, negative b plus or minus b squared minus 4ac. Sorry. There, I put the curly braces around the wrong point. So you'll get something like this, where you basically use the frac and have nested arguments. So the numerator here is just going to be this top term that's inside this set of curly braces. And then the denominator is in this set of curly braces, and then you nest in the squared here. Okay. So going back to our slides. Yeah, so one thing we can do, if you want to try this, I'll leave this as a kind of a mystery, is try to figure out how to make this bigger, but still keeping it in line. So this is going to require a little bit of Google to try to figure it out. And the answer is in the slides. So if you want to try that afterward, you can do that. So the next thing we're going to talk about is packages. So packages are kind of like the import statements in this. So there's a few that are very useful: AMS Math, AMS Font, and AMS Sim. And so they allow us to do a lot of cool things. So for example, if we go to packages.tech, if I just compile this without any packages, I encounter some errors. So this is what I get. It doesn't format anything correctly, right? But I can have special environments. So for example, AMS Math has a special math environment called the gather environment, which I can use for a series of equations. So if I import it, now this is going to work. And I'll see if I zoom out, I get the equation and it'll be labeled because I'm using the gather environment. Excuse me. And if I import the fonts or the symbolic packages, I'm also able to get the R symbol for the real numbers. So importing packages is also, I think, an important thing to keep track of. And that's something you can easily figure out with Google if you're not sure where something comes from. So one thing that I used here was a math environment. So using for multi-line equations, you can use something like the gather environment in order to go through all of the, keep all your multi-line equations together. So for example, in additional commands, which is over here, what I can show is that if I want to solve, let's say I'm solving this problem and going down the list, instead of using a series of like math equations, I can use this gather environment and just list them down the line, right? So I list the steps in my process one by one by one in that gather environment. And this makes editing very, very quick and easy. And there's a couple other ones that I have listed here. So if you have the section, that's going to list the section. If you have subsection, that's like a subheader. Enumerate is for numbered lists, and itemize is for not numbered lists, and you can nest those. So these are all different ways you can organize your, basically your questions and such, and organize your output. But all that any of these are is one of these commands. And one little caveat I'll mention here is you'll notice that greatest workshop is numbered, but greatest challenge is not. That's because I put this asterisk here. We can modify that at will. So if I were to switch these two, what we would see is that this is not numbered, but now this is numbered. Any questions on this content that's in this additional command? So that can be some of the math content from prior, the sections, or stuff like that. But these are just some very common organizational commands that people use. And all of them have this very similar structure. So seeing no questions, I'm going to kind of move on towards, oh, is there a question? Are those equations centered because they use gather? Yes, great question. Gather is for organizing equations. It automatically centers. So we can modify kind of what we want to use. So if we use an aligned environment, for example, this one would basically align them on the right side to keep them all in the same place, right? So each of these has slightly different behavior. Aligned also has this very nice feature where you can set exactly where you want to align using an ampersand. So one cool thing, let's say we want this to be left justified. We can do this, and all those ands are going to line up, all the ampersands. Let's say you don't want that, and you want all the left ends to be justified, which is what it was doing prior. Then you can do it like this, and it'll align it that way, except for the last one. The last one, you want to be, let's say, a little bit different. So you can, all the ampersands are going to line up in the aligned environment. And so you can basically customize the alignment to however you want it to be aligned. That's a great question. So yeah, in terms of like specific behavior for each of these, there's like certain nuances to each of them. But you could, one thing that I like highly recommend is like using Google to figure, like say, okay, I want to get this behavior. What's the right command for that? Generally, these are like the tools in the toolbox that you'll use often. So gather is for gather and aligner for aligning equations with that particular difference. Enumerate and itemize I for lists and such things. Okay, now we're going to, any other questions before we move on? Okay, now towards the end, I'm going to discuss how we basically go faster. So there's a couple of things that I highly recommend if you want to really go fast and kind of edit your homework really quickly. The first one is to use templates. So a lot of classes have templates or style files pre-made that you can use. So one example that I have pulled up in this repo is a sample 70 homework. So if we look at this style, it has a lot of random formatting options. Oh, sorry, I'm at the end. So it has a lot of automatic package imports, which you don't have to type every time. It has a lot of formatting options. These are all different formatting options for what font they want and such. It has a title set up all for you. Lots of common commands, for example, XOR or things like that, and so on and so forth. Lots of common symbols. And so if you use one of these style files, that will be like customized to what command you're using in the course, right? And so, for example, here, instead of using like a section, they use the question one. So that's a customized thing they do for this course. And it automatically gives you the right font and the right size and organization. But under the hood, this is just this, like the section command with some formatting changes. If I were to replace it, you'll see the slight differences in, here it's almost exactly the same, right? So a lot of this like atypicality is like just how they organize it. But under the hood, almost all of this is stuff that you've seen before, right? With some additional advanced formatting options. Okay, and if we go through this, it's an itemize, which is just that unordered list I showed you. This is like an italics thing. This parts here is a special version of an enumerate, which specifically uses the A, B, C part structure. But if I were to change this to enumerate and go down here, and change these to items. That's the other thing. And this is the exact same code I showed you prior. This is going to basically do the exact same thing, the exact ordered list. It just has different labels on the side. So if you have a provided style file, then editing it is actually really like not too bad. It's just the basics that we've covered already. And another like little hint for homeworks is use ClearPage and then assign pages sequentially. So have each problem on a single page and then use assign pages sequentially to really quickly upload. Any questions on this slide? So all you have to do for the template files is basically you can make a project and then copy it a bunch of times. You can, if you want to be a bit more fancy, you can use a like style file and then import it, and it'll automatically do all the formatting and imports for you. Whatever you want to do, this is something I highly recommend. So if people are interested in this, I can also like at the end of this show some of my own templates for other classes. But that's that. The next thing is adding your own commands. So for example, to get the real numbers, you do this thing called, you Google it, you can find this thing called mathbb.r, and it basically makes the number all fancy, right? And instead of doing that, you can make a new command and make /r this special command. And you can see this in a lot of the style files or templates as they do this by default. It's another thing I highly recommend to kind of speed up your LaTeX writing. Then finally, I recommend like trying to improve how you're editing. This is a high-level overview to cover the basics, but I also wanted to cover like how do you get really fast at LaTeX. So what you do is like kind of practice the language a bit. You'll become more and more comfortable with various like syntax, and depending on what class you'll take, you'll use different syntax. So if you're doing 16b, you might really learn about matrices and you'll become really comfortable with matrix LaTeX syntax. If you're doing 70, you'll be more comfortable with like modular arithmetic syntax, so on and so forth. And try to learn what editor you're using. This is meant to be an agnostic tutorial, but for example, Overleaf has a lot of like cool specific features. So for example, I use Vim key bindings to speed up my editing, as well as some of the autocomplete features that are built in. In addition, I use some of these hotkeys in order to accelerate my editing, though a lot of them are built in with Vim. I also, this is like very true if you're using a custom setup. So one thing that I can briefly show is here, if you have, this is an example custom setup where this person is able to, has a system for taking notes in real time using a LaTeX Vim custom setup. And basically what they do is they use a lot of customization to have very quick editing with snippets. And so for example, if they type in sign and tab, it automatically expands into their signature. And they make like 1 million of these, and their LaTeX goes super fast. So that's not something that like is probably going to be useful for you, but like it's worth thinking about how, but you're spending a little bit of time to become more familiar. Okay, I have some challenges prepared to like kind of test your understanding and like, have some fun. What are y'all interested in? I can cover any topic y'all are interested in, or cover some of the more advanced things in more detail. Augmented matrix with Gaussian elimination. Okay, I mean, if no one has other requests, basically for matrix syntaxes, it's like very helpful to have some sort of auto format. So like, I'll talk about matrices. Okay, if for example, if you look at like what this guy does, for example, if you autocomplete a matrix so that all you have to do is like press tab a bunch of times and it'll automatically do it for you, it's not too bad. How would I recommend formatting stuff? Okay. This is for homeworks, I'm assuming, right? Because it's a little bit different for, my advice would be different for like research papers and stuff. So formatting, I recommend, so if you have a class-based formatting, you can just use that. So for like 70, that's a good option. So let's go to, so a good example. Let me show, I'm going to briefly, I'm going to just quickly show off my setup for class I took last semester. So this is my setup for non-collaborative editing. It's like for proof stuff. Okay, for formatting proofs, I like to use, there's a couple of different ways you can do it. Let me see which of these ones has good proofs. Scribe might have good ones. Let me find, this probably has a proof in here somewhere. So this is some of my Scribe notes. This is not probably the prettiest thing to do, but for things like proofs, what I really recommend is if you want something basic that's really functional, what I did is like basically go to a like 1, 2, 3, 4, like use an enumerated list. Yeah, so it's more math simple. So like for stuff like this, what I tended to do is basically use enumerates a lot for your basic like bread and butter. And if you're using like a text-based one, and if you're using something which is more mathematical based, I recommend using something like a gather, right? So you can mix and match using some things. So for example, if in this case for the recap proof, what I did is I basically used the enumerate here with some small things in the middle and use some functions in here. This is live scribing, so this is like not as well formatted as it could have been. But I think if you wanted to improve this, the primary things you would do is you would break these down into, you would probably use a gather environment instead, right? And use less text. So if you want to use something that's like that, in additional commands, I put something which is like, I think a good template for an ICF LaTeX workshop. If we go to additional commands, and I'll resume share. So for proofs, I recommend for your formatting, use an align environment, right? Because you'll get this very nice numbering here, and just figure out what alignment looks best to you. Okay, so that's one thing you can do. And also, if there's anything other way people do it. Yeah, so if you want to do something that's a bit more like formal, usually what you can do, like it depends on how text-based or not text-based you want to be. If you're text-based, then you can just use like blocks of text separated into like nice short paragraphs. If you want to be really mathematical, something like a gather or a line environment works well. You can also mix and match here using things like text. So what I can do, so the way these environments work is that it aligns based on where like the first and second ampersand. If you want to be really fancy, this is what you can do, right? So I'm going to basically and write explanations. I'm going to write explanations in here. So for example, plug in text. So I want it to be really specific. Plug in stuff, and then here I do subtraction, and here I do square root. And if you see how this formats, you'll get them all aligned into one nice explanation and things on the side. So depending on how you want to format it, if you want to do a line by line proof, I use something like this most of the time. So hopefully that answers your question. But yeah, all you need to do is like kind of like mix and match these basics, and you can get really great looking documents. I think people, yeah, that's, I think it is 6 o'clock. So thank you all for coming. Yeah, in terms of like I'll be free to answer questions afterwards if you have anything more specific. I'd love to answer questions. Yeah, thank you all for coming. Hope to see you around. And Kahoot, stop recording. Michael, did you have a specific question? Or? Oh, okay, let's see.